Question B9 reads, the following diagram shows apparatus that can be used to electrolyze concentrated, aqueous sodium chloride. The diagram shows a cell with a graphite cathode on the left and a graphite anode on the right. The electrolyte is concentrated sodium chloride solution. Part A says, the electrolyte contains sodium plus and chlorine minus ions. Write the formula of the other two ions in the electrolyte. Concentrated sodium chloride solution also contains water, which partially ionizes into ions. The other two ions are hydroxide ion, written as OH- and hydrogen ion, written as H+. Before you start answering the part for the equations, you need to know what reduction is and what oxidation is. So reduction is the gain of electrons, it occurs at cathode, and oxidation is the loss of electrons, and it always occurs at the anode. Never forget those definitions when you're asked to answer questions on electrolysis. Now let's get back to business. Part B says, construct equations for the reactions at the Part B, Part 1, cathode. At the cathode, reduction takes place. Hydrogen ions are preferentially discharged over sodium ions because sodium is far too reactive to be discharged. The equation is 2H plus 2 electrons gives H2 gas. Part B, Part 2, anode. At the anode, oxidation takes place. Chloride ions are discharged first over hydroxide ions because the sodium chloride solution is concentrated. The equation is 2Cl- gives Cl2 gas plus 2 electrons. Part C says, suggest why the concentration of sodium hydroxide in the electrolyte increases as the electrolysis proceeds. As electrolysis continues, hydrogen ions are removed at the cathode and chloride ions are removed at the anode. The sodium ions and hydroxide ions that remain in the solution are not discharged. As more and more of these ions accumulate in the solution, the concentration of sodium hydroxide gradually increases over time. Part D says, state the chemical test for the product at the anode and state one of its uses. The product at the anode is chlorine gas, and its chemical test done by holding a damp blue litmus paper near the gas. As a result, it first turns red due to the acidic nature of the gas, and is then bleached to white due to the oxidizing nature of chlorine. Then the one use of chlorine is that it is used to sterilize drinking water to kill harmful bacteria and make it safe to drink. Part E says, in another experiment, 4.6 grams of sodium metal was produced by electrolyzing molten sodium chloride. Calculate the volume of chlorine gas produced at the same time at room temperature and pressure. Given the following overall equation, 2NaCl gives Cl2 plus 2Na. Let me work through this step by step. First, find moles of sodium produced. Molar mass of Na is 23 grams per mole. Moles of Na equals 4.6 divided by 23 equals 0.2 moles. From the equation, 2 moles of Na is produced alongside 1 mole of Cl2. So moles of Cl2 equals 0.2 divided by 2 equals 0.1 moles. At room temperature and pressure, 1 mole of any gas occupies 24,000 centimeters cubed. Volume of Cl2 equals 0.1 times 24,000 equals 2,400 cm cubed. That gives you your 10 marks for question B9.